and PIN. So basically, you key in the PIN in the reader. The reader will send this to the card. The card will verify the PIN. However, so in this simple attack, so basically the device in the backpack will intercept the signal sent from the reader to the card, and then now modify this message to a different one. So basically, the message from the reader now is not the PIN to be verified. It's changed to another message telling the card the transaction is authorized by signature. Then the card will not really verify the PIN because the card will believe this is done by signature. Then the card will just reply yes, okay, and then the response sent to the reader. So the reader believes the card has already verified the PIN. So the reader will accept, and then transaction will go through. So essentially, this is just a simple flaw ignored by the designer of the whole system. So nowadays, actually in Australia, we don't use signature anymore. So for all the credit card, we must use the PIN. That means the credit card will no longer accept the message saying the transaction is done by signature. So the credit card will every time verify the PIN. So if we allow both like PIN and the password to be used, then actually we need to change the design. For example, at least you need to use two different signals to tell the reader. So if you say this is verified by PIN, then you use one signal to say okay. If it's verified by signature, you use a different signal to say okay. You don't use one single signal to say yes. If you use one single signal, then actually we cannot tell whether the card really verifies the PIN or not, or the card is told that the transaction is done by signature. All right, so that's one of the flaws actually found in this chip and PIN system. So nowadays, I think this flaw has been addressed because this was several years ago. Okay, right. So this is another type of chip authentication. So it's to authorize the transaction. For example, you can, if you also have a card with a chip, so you can insert the card into a device, and then you can key in the PIN, and then this device now becomes like a authorization token. So every time you want to do a transaction, you can enter the transaction number, it will generate the authorization code, and then you can enter the authorization code, the bank will perform the transaction. So now it's not just for login, but for transaction authorization as well. Right, some games actually also use two-factor authentication nowadays, because the accounts nowadays actually the account for many games are also variable. You may have some valuable weapons that can be sold, can be sold to others and so on. So we need to protect those accounts as well. Okay, so that's two-factor based on like a smart card. So the chip, you can treat this as like a smart card based authentication. So the other factor we can use is of course biometrics. So biometric is basically something you are, right? So however, we should not use this biometric authentication as the sole authentication mechanism, because biometric data can be obtained by the attacker easily, right? So after I finish this class, probably you can find my fingerprint, for example, on this pad, maybe on different places of the desk. So we should not simply use the biometric unless, say, you have physical control of the device like your iPhone. In this case, you can make sure other people cannot physically get your device, then you can use biometric. But if, say, I simply use my biometric data to log in this public PC, and my fingerprint actually is left in different places of the desk, then people actually can collect my fingerprint and log in. So similarly, if you use like voice or face recognition, someone may record your voice or like take a picture. So depending on how the robustness of the system. So for some simple system, even you take a picture, you may pass the face recognition authentication. So in general, biometric is used as like an additional factor on top of some other factors. So we usually should not use the biometric authentication alone, unless you have physical control of the device. So other people, you make sure other people cannot touch your device, then you can use the biometric authentication. So there are different ways you can do the authentication based on your biometric data. Right, so corresponding, so basically the two-factor authentication, actually sometimes we can have overlap between two-factor authentication with another authentication mechanism, which is called a two-channel authentication. So in this kind of authentication mechanism, we use two communication channels to pass information. So one typical example is, for example, you use your smartphone, right? So when you log into a website, so you will need to use your long-term password and maybe also the one-time password from your mobile phone, right? So in this case, actually the one-time password is sent through a different channel, which is a telecommunication channel, like the 4G channel, instead of the computer network channel. So in this case, we can have two-channel authentication. And we can also have overlap. So you can have like a scheme which implements two-factor authentication as well as two-channel authentication. Okay, so the last part, so we finish this part and then we have a break. So the last part is about this capture. So capture is basically, we can consider this as an authentication mechanism, but actually it's like later we will see, actually this is more on the denial service, anti-denial service mechanism. So capture basically is some mechanism we use to distinguish machine from human, right? So, for example, if you want to log into a website, sometimes you will see a picture, a distorted picture. So you need to recognize the letters inside the picture, and then you need to key in the words in the picture, and then you can like go through authentication. So in this case, actually, we try to prevent some attacker using like a brute force. For example, the attacker may try to brute force an account. If there is, say, no limitation on the number of trials, then attacker may use the machine to brute force. And this is also related to denial service because, as I said, so if you want to perform a denial service, the attacker may generate a huge amount of requests to connect to the server. So in this case, so the server may be overwhelmed, the server may be down. Okay, so capture actually can prevent this kind of attack because the server will send you a challenge. The challenge is this capture, the distorted picture or some like even some like audio or video. So in this case, you need to answer the question specified by the capture system in order to go to the next step. So in this case, so if we can prevent the machine from providing the correct answer, then we can prevent the denial service attack or like brute force attack and so on. So in general, so we need to design a mechanism which can be easily solved by human being, but difficult to be solved by machine. So that's the requirement for a secure capture system. So in the like old days, we always use a distorted picture, but nowadays we have a more advanced capture schemes. For example, 3D capture. You may need to wear a glass in order to see the answer in the 3D picture. Okay, so these are some examples, right? So basically, the design of the capture system is based on the capability, the difference between the capability of the machine and the capability of the human being. So if we have some like AI program that can solve the problem underlying the capture, then basically the AI program can like bypass this capture authentication. Right. So this is just a cartoon to illustrate how we can distinguish like an AI machine with a real person by using capture. Okay. Okay. So this is basically the common technique we use for denial service. But actually, we can also use it for authentication, right? So imagine So you can, maybe you also have like a one-time password device, right? So in this case, you don't just press button to generate one-time password. So instead, so the server can send you a capture picture. So now only the human, the user, can read the message in the capture, and then you key in the message, for example, the digits or some other input. You key in those characters in the device, then the device can generate, say, a one-time password. The one-time password now is corresponding to the challenge given by the capture. So now in this case, you enter this result, and then you can go through. So in this case, basically we can have we can use capture as a mechanism to distinguish like a human from machine, and also to deliver a challenge for the user to pass the authentication. So we can combine authentication with capture by embedding the challenge inside the capture. Right? For example, in the which it was two-factor, you can just put a question inside the capture. And then you need to first recognize the question. The machine cannot recognize, only human can recognize. Then you need to know the answer in order to pass the authentication. So capture is widely used in many systems, but nowadays many captures were broken because the pattern recognition technique actually also improved a lot in recent years. So if we can use some AI mechanism or algorithm to recognize the message inside capture, then basically we can break the capture authentication. So this is an example of a 3D capture. So basically you need to tell the position of different objects within this 3D picture. And there are some other 3D captures, and some of them may require a special class to be read to see the secret, to see the message inside the 3D picture. And if you want to implement capture, you can go to this website. They provide a lot of resources for you to implement the capture in a web, like a web page or web server. And then this one is to break the capture. So they provide some resource to break the capture implementations. Right. So that's the second part. So we look at some other authentication mechanisms beyond the basic password. Right. So we have a break. So after that, we will look at a new topic, which is access control. We have a 10 minutes break.
So.